Okay, in this series of videos, we're going to take a look at concepts and calculations around this notion of the time value of money. With the time value of money problems, there are several different types of calculations that we can work on. So one category or type of problem we can solve is the difference between future value and present value, where we're solving for one of those two things. And that's where we're either compounding a number, growing it over time, or we're discounting a number where we're reducing it as we bring it back in time. So a future cash flow that's received at some point in the future, we bring it back to today, find the present value, then we'll be discounting. There are a few different types of cash flows that we can deal with as well. So one kind of cash flow is a lump sum. So that simply refers to a one-time cash flow that we would be either discounting or compounding, either finding the present value or the future value. Another kind of cash flow that we could deal with is an annuity. And so that is a series of equal payments that occur at equal intervals over a period of time. So we can again find the future value or the present value of those things. We could have uneven cash flows where we have a series of unequal cash flows over time. Again, finding a present value or a future value of those uneven cash flows. And then finally, we could even mix up some of these types of cash flows. So we could have a lump sum bolted onto an annuity, and again, figuring out a present value or a future value of those sets of cash flows. So those are some of the kinds of problems. And then for any of these cash flow or any of these time value calculations, we can solve for the present value, we can solve for the future value. We can also solve for the number of periods or how long it takes to do something. We can solve for a periodic interest rate. And sometimes that comes into play where you're trying to figure out what interest rate do I need to earn on my investments to reach a goal, or what interest rate am I paying by virtue of these payments that I've been quoted. And then the last thing that you can solve for with time value inputs and calculations is the periodic payment that's required for a certain thing. So in terms of where or how we do those calculations, in a calculator, there's the PV key on most time value calculators is going to solve for the present value. There's an FV key that solves for the future value. There's an N key that will solve for the number of periods, an I key for the periodic interest rate, and then a PMT key that does the periodic payment. In Excel, if you're doing these calculations in Excel, we have the PV function. So those little things in parentheses there are going to be all the arguments that you put into the function. These things inside the parentheses that tell Excel what to use as the inputs for the calculation. For future value, we use the FV function. For the number of periods, we're going to use the NPER function. For the periodic interest rate, we'll use the rate function. And then finally, for the periodic payment, we'll use the PMT function. So you can see there's a fair amount of overlap between a calculator and Excel in terms of how we do these calculations. And in the slides that we're looking at through the rest of this video presentation, we'll be doing calculations in both Excel and with a time value calculator. So you can see how these things are done, maybe get a little bit of practice working on them. So let's go ahead and move forward to the next slide and take a look at future values. So this first kind of calculation that we're going to do is finding the future value of a lump sum. So this is a situation where you stick in some money, you're investing it over a period of time, and you're wondering how much is this going to turn into over time. And in particular, we're sticking in one chunk of money, one-time cash flow upfront, and then finding out what it's going to be at some point in the future. So we got a formula here, and by the way, the quick note here, there's many types or many ways to represent this formula, where we have the future value is equal to some cash flow. In here, I've denoted that as L, where it's a lump sum. That could also be a C for a cash flow. It could equal the PV for the present value, some number that you're starting with. And then we're going to multiply that times this quantity 1 plus R. That's in parentheses, so that 1 plus R is 1 plus the interest rate or the discount rate, and in particular, maybe more precisely, the periodic interest rate or the periodic discount rate. So the reason I'm distinguishing that is if we were talking about things happening on a monthly basis, we would want to take an annual interest rate and divide that by 12 to come up with a periodic interest rate. And then finally, we're going to have the number of periods denoted here with the n. We're going to raise all of that that thing in the parentheses to the nth power and then find the answer. So let's look at an example here. Number one, what is the future value of $25,000 invested for 35 years at a rate of 9.5%? So with the formula, it's going to be $25,000 as the lump sum multiplied times 1 plus r. So in this case, 9.5% is the rate. So 1 plus 0.095, we'll have 1.095. And we're going to raise that number to the 35th power. Now, no, we're not taking $25,000 times 1.095 and then raising all of that business to the 35th power. It's the 1 plus r. It's that piece in parentheses that's doing the exponent. So just a quick order of operations sidebar there. So if we do that calculation, we can do it without using any special kind of calculators, and we'd come up with $599,010. And let's look at a second example, and then we're going to do this with a calculator and with Excel. So the second example, what is the future value of $25,000 invested for 35 years? But now we're going to assume monthly compounding using that same 9.5% annual interest rate. So here we would take the $25,000 as a lump sum, and our interest rate, or our periodic interest rate, our periodic discount rate, is no longer going to be 9.5%, but it'll be 9.5% divided by 12. And that's represented by this 0.007917. So that's going to be equal to, or roughly equal to, 9.5% divided by 12. There's still a little bit of rounding going on there, but that's close enough. And I'll show you in the calculator how to make this very precise, even if you can't necessarily see all the decimal places. But if you do it right in a calculator, there's not going to be any rounding issues, and you'll have an exact answer. And then we're going to raise that to the number of periods. And so in this case, we've got months. So we're going to take 35, multiply that times 12. And so we would have 420 months here. So we have a monthly periodic rate and the number of months as our n, in this case, 420. So if we stick all that stuff in our calculator, we're going to come up with an answer of 685,935. So let's look at how we would do that with Excel and then with a time value calculator. So in Excel, you're going to use the FV function, the future value function, and there are three required inputs and then 2 optional ones. And so those optional inputs are denoted with these brackets, so we can determine what that lump sum payment is, if any, and then the type tells Excel whether it's a beginning of period cash flow or an end of period cash flow. So if we ignore either of those, Excel will have certain assumptions. For the lump sum, it'll assume 0. If we ignore the type or don't tell Excel what type of cash flow it is, Excel will assume an end of period cash flow. So let's just look at this, and then we'll do it in Excel. The periodic interest rate in the first example was 9.5%, so that's an annual rate. The number of periods would be 35 for the years. The periodic payment in this case is 0. And in the lump sum, we're going to need to stick in a number here. And I've put in a negative 25,000. The negative denotes the direction of the cash flow. A negative cash flow is one that we are investing. So this is how we would enter it into Excel. We'd put in a negative 25,000. We submit those inputs, and we're going to get an output of $599,010, and that's the same thing we came up with our other calculation. If we do it monthly, we would have 9.5% divided by 12 as the input for the periodic rate. Our number of periods would be 35 times 12. The periodic payment again is still 0, and our lump sum payment is negative 25,000. So that would be the amount that we invest up front. And again, we would have that same answer we had before, 685,935. Let's just go to Excel real quick and do these calculations. So the first thing I'm going to do is set up my Excel to have these 5 time value inputs, and we're going to need to allocate or input 4 of those things to figure out what the 5th or the unknown item is. So in this case, our present value, we're going to put in negative 25,000. That's the amount that we're starting with, or the amount that we're investing. We're trying to figure out what the future value is, so we're going to ignore that for now. The number of periods without the monthly compounding, if we just do that initial example, we're going to have 35 years as the number of periods. The interest rate is 9.5%, so we're going to put in 0.095. And for the payment, we have 0. There's no periodic cash flows that are happening. And so I can go over here, and I'm going to go on the side to show that this is the calculation that we're doing. I would type in FV, and notice that Excel asks me what the inputs should be. So the rate, it tells us, it shows in kind of bold what that should be. So I'm going to click on this interest rate cell that shows what my rate is, my periodic rate. I hit comma, and now Excel asks me what is the number of periods. So I'm going to click on the 35, comma, and Excel is going to ask me what the payment is. I can link to the payment cell. For what the present value is, I can click on that cell, and then I can ignore it. I can ignore the type if I just close the parentheses now, or if you want to be very particular, I can hit comma, and it'll tell me 0 means an end of period cash flow, 1 is a beginning of period cash flow. For most calculations we're going to be doing, 0 is the default. We're going to be doing end of period cash flows. So I can either put in 0 here or just ignore it. I'm going to go ahead and put in the 0 just for grins, close my parentheses and hit enter. And once I format this, I will have the answer that we found in the other calculations, $599,010. Now let's go ahead and do this, do the adjustments or the tweaks for the monthly compounding, and then we'll wrap up this particular video and we'll pick up with the next slide in the next video. But here we're going to change the number of periods not to 35 years but to the number of months. So I'm going to put in a little formula here, 35 times 12, and I get 420 months as my number of periods. And then I need to do an adjustment to my interest rate. I need to divide that by 12 to get a monthly rate. And my monthly rate is going to be that 9.5% divided by 12. Notice Excel shows, depending on how many decimal place I ask Excel to show, it's going to show anywhere from a 1% all the way to much more precisely what that interest rate is. It doesn't matter necessarily what I'm showing in terms of the number of decimal places. The calculation doesn't change. Excel is using all of that information that's there. It's not rounding it at all in this calculation. So it would be much better, and this is what I would prefer and actually require, is that you put in this kind of an input, 9.5% divided by 12, instead of doing a little side calculation and then typing in 0.79%, because that will introduce rounding and it'll introduce errors into your calculations. So notice my answer, $685,935. That's what we calculated before. So we're getting the same answers all across the board. Let's look at this in a calculator real quick. So first thing I'm going to do is format my calculator, kind of get it ready to do these calculations. So if your calculator right out of the box looks something like this, I'm going to hit clear. I'm going to get it to show 4 decimal places. So I'm going to hit the second key, the format key or that decimal key, and it tells me or asks me, how many decimal places do you want to show? I want to show 4, and then it's telling me I need to hit enter to make this all work. So I'll hit the enter key. And now I'm ready to roll. So again, my number of periods, I'm going to hit 35, type that into the N key. My interest rate is 9.5. Notice that with calculators, you put in that number as a whole number, not as a decimal. So it's not going to be 0.095, it'll be 9.5. My present value is 25,000. I'll put a negative sign there and use the input. 0 is my payment. And then with this particular calculator, the TI-BA2 Plus, you need to hit compute and the future value to get the thing that you want. So you're going to always hit compute and then the button that indicates the answer you want. So in this case, again, $599,010. If I tweak my number of periods to be 35 times 12, I get this number. I can put that into the number of periods. My periodic rate is going to be 9.5 divided by 12. I do that, stick it into the periodic interest rate button, compute my future value, and again I have the same answer that we've had before. So these are the different ways to do it, the calculations, one with a formula, which will become very cumbersome very quickly, one with Excel, and then one with a TI-BA2 Plus calculator. We'll continue on in the next video with looking at finding present values of lump sums. And I'll see you there.